So we finished talking about how to rationalize the denominator when we have a single radical in the denominator. If there's more than just the radical, then we have to do a little bit more work to rationalize the denominator. So this is where the idea of conjugates comes in. And the definition of conjugates is two expressions that contain a sum and a difference of the same two terms. So one has to have a plus, one has to be a minus, and this is a term that we really only use for expressions that contain radicals. And so they have to be the same two expressions. So if you look at the example here, you notice I have the square root of 6 and the square root of 6, and the square root of 5 and the square root of 5, but that one of the expressions has a plus and one of the expressions has a minus. That's what they have to have. Now, they don't both have to be radicals. You could have 2 plus the square root of 2 and 2 minus the square root of 2. 2's not a radical, but that's okay. It still works in this instance. When we multiply conjugates times each other, something kind of interesting happens. And if you look at the example down here that's in the box, you'll see if I multiply the square root of a plus the square root of b times the square root of a minus the square root of b, if I look at what I have left over, it's a rational value. I don't have any radicals left at that point. And so that's kind of how this works. If you remember back to when we were multiplying and factoring polynomials in Algebra 2, the difference of squares said if I have a squared minus b squared, that factors to a plus b and a minus b. Well, that's exactly where this multiplication pattern for conjugates comes from. It's just the difference of two squares. So here's my a plus b and my a minus b. So that gives me a squared minus b squared. But in this case, a and b, we're talking about radicals. Remember that whenever you square a square root, it's going to cancel out. That's why we get just a minus just b. That is the big idea when we're going to rationalize a denominator that has two terms in it. So if you look at example 11, my denominator contains the square root of 3. So that's the radical I need to get rid of. Simply multiplying by the square root of 3 is not going to be enough because I have to also multiply this 5. If I multiply 5 times the square root of 3, I'm still going to have the square root of 3. The way we get rid of it is to multiply by the conjugate. So this one has a plus, which means the conjugate is going to have a minus. Whatever I multiply in the denominator, I have to do the same in the numerator. So here's how this is going to work when I multiply this out. I'm going to distribute the 7 in the numerator. 7 times 5 gives me 35 minus 7 root 3. So that's our numerator. Over, in our denominator, because it follows the conjugate pattern, we're going to do the first term minus the square of the second term. So we're going to square the first term minus square the second term. The first term is 5 squared minus the square root of 3 squared. And so now when we work that out, you can kind of do some scratch work off to the side. That's fine. I always kind of do it underneath. I know this is 25. This is going to be 3. So all together, when all is said and done, I'm going to have 35 minus 7 square root 3 over 25 minus 3, which is 22. And so now that's our answer. One thing you want to watch out for is if you can simplify, you should. But if you remember from before, you're going to have to factor out the GCF in the numerator to be able to do that. Let me just give you kind of an example off to the side of what I'm talking about, because that probably wasn't clear. So let's say that I had 8 minus 2 root 5 over 10. I'm not sure if that would actually ever happen, but we have to look for the GCF in the numerator, which would be 2. This is 2 times 4 minus the square root of 5. And now this 2 and this 10 I can simplify. So this would simplify to 4 minus the square root of 5 over 5. We can't just simplify this and get 5, or we can't just simplify these. We have to be able to, whatever you're dividing by, take it out of all the factors in the numerator, not just one. So that's something to watch for. If you want to go ahead and pause and try the second example on your own, then come on back and check it in just a second. That would probably be a good idea. The conjugate here is going to be 4 plus the square root of 5, because I already had the minus. Again, I have to distribute on the top, so I get 32 plus 8 root 5 divided by the first one squared minus the second one squared. This is going to give us 16 minus 5, so 32 plus 8 root 5 over 11 is what we get. And if you look at that, 32, 8, and 11 have no common factors, so I don't need to worry about trying to take that any further. So that is how you rationalize a denominator that contains two terms.